Welcome back, Earthlings. Today's episode is sponsored by Mr. Tollison, who provided me with these M&Ms. How do you feel about that? Feel pretty good. Lesson 87, folks. This will probably take us 2 episodes here today because I got a lot of different examples to go over today of ways to do factoring with polynomials by grouping them in some different ways. Today's kind of like a strategy lesson. I might probably only get through the first 3 examples in this episode, and we'll do another one and I'll cover the other couple of things to think about. Okay, so today you're just going to see lots of nuts and bolts. There's not going to be a whole lot of application except like you're going to need this later kind of thing, so I apologize for that. But our job really today is to learn how to take something that looks really clunky and big and condense things down and turn it into a factored form where we just have things that are going to be multiplied by each other, but the things themselves are much simpler than they were before. So we're going to have big, long polynomials, and we want to see if we can put it in a kind of a tighter package, like in 2 sets of parentheses, where if we multiply it all back together, we get the long thing. We're going to need that skill and lots of math to come, so we're going to do a lot of practicing with this to see if we can nail this down and get this skill in our skill tool bag. I'm going to take this first one here and I'm going to group it in a couple of different ways to look for things that I can separate out and simplify. I've got 1, 2, 3, 4 terms here, and we've got x's and y's and only x and only y. And so if I looked at just the first 2 together, I see that both the first 2 terms have x's in them. So there's like a common factor that I could pull out of there. So I'm gonna start with chunking this thing into 2 halves. Okay? I'm going to look at just the first half and look at what I could pull out of that. And then I'll look at the second half and see if there's stuff I can pull out of that. I can see here also in the first half that I've got some numbers, and both of them have a factor of at least 2 in them. So I would be able to take out a 2, and I would be able to take out an x and be left with some extra stuff. I'd be left with an x, and I'd be left with 2y. Okay, do you see that? Well, kind of. Probably you kind of see that. Now I'm going to look at the back half of this equation. I'm going to see that even though their letters are different, they both have factors that are the same. They have a factor of 7 in there, and there'll be some leftover stuff. So if I factor a 7 out of this and a 7 out of this, I'll be left with x plus 2y. Now, if you notice that I was able to pull stuff out and be left with the same exact thing in the remaining business in the parentheses. Okay? That's one thing I could have done here. And I'll write that off to the side here. I got 2x times x plus 2y and 7 times x plus 2y. And so I've kind of grouped and factored, and there'll be one more step to finish that one off and clean it up even more. But I have to prove it to you first. Now I'm going to take that in a different way. I'm going to rearrange those parts. I'm allowed to do that. It's just addition, so I'm going to use the commutative property, which says that I can put these things in any order that I wish to if I'm just adding. And I'm going to put stuff with like strictly x in it together, and I'm going to put the things that both have y in it together. So I regroup these things. So these have x's, these have y's. Now there's an x in there, but I'll take care of that. And I'm going to look at the front half of this. I'm going to pull out that x that they have in common, and we'll have left over 2x and 7 if I factor out x. Then I'm going to forget about that. I'm going to look at this half here, and I'm going to factor some stuff out of there too. And it looks like if I could factor out a 2 and a y, what's left over is 2x and 7. Now I did that in a different way, but I still get the same kinds of chunks in there. I still get the same thing left over in the parentheses. I will finish this off here in a minute, but let me do a little bit of visualization for you to see what it is or why it is I'm going to do what I'm going to do with these answers to show you that they're the same thing. Maybe you can already see that that answer up there and that answer down there, they have a lot of things in common. I'm going to show you that they're exactly the same thing. All right, so let's talk about the distributive property a little bit. The distributive property means that we can take something like a plus d and distribute it with something like b plus c. Like, let's say this is distance b and distance c and distance a and distance d, and I'm going to like put those together, but I'm going to do it in pieces like I'm foiling. So a plus d times b plus c, but I just put it up here in this grid. And so we got a times b here, and a times c here, and b times d, and c times d. It'll be all four of those things. And so our answer, ab plus ac plus bd plus cd, is exactly the same thing you get if you did the distribution here. First, outside, inside, and last. There's the same exact four pieces. AB is that. We have AC, we have BD, and we have CD. We have all four pieces there. It's the exact same thing. Now, what if I just take this whole side here and just call it B plus C rather than chunking it into pieces? The multiplication would look like this. This would be A times B plus C, and this would be D times B plus C. That is, I would have A, B plus C, plus D, B plus C. But those are the exact same things here. I just divvied it up a little bit differently. If you can see here, I have A plus D. A plus D. Both A and the D got multiplied by B plus C. These are equal to each other. These are the exact same thing. It didn't matter if I split it up or if I put them together. I still get all the parts in there. If I distribute this, I get A times B, it's that. A times C, that's right there. I get D times B, that's right there. And I get D times C, that's right there. They're the exact same thing, just kind of written in two different ways. I know that's a lot of junk on there. You can hit pause and copy it down, but I'm going to go ahead and erase it and move on back to the other problem. With that in mind, what I just showed you, I can rewrite this as 2x and 7, both being multiplied by x plus 2y. And that gives me just two chunks when before I had all this extra stuff. And by the same exact reasoning, I can take x and 2y, and both x and 2y are being multiplied by 2x and 7. Okay? Now, even though I wrote them in a different order, they're exactly the same thing, which is just to show you that I can rearrange these in any order that I want to and do this factoring by the front half and factoring in the back half, and then putting these things together into what I was looking for, a simplified factored form of one sum or difference multiplied by another sum or difference, like the AD and A plus D and the B plus C, having all four parts. Okay, it's better to kind of have it in this tight, nice, compressed version than it is to have things spread out all over the place. I got to clear the board here for a minute. Again, you can pause it, go back 10 seconds and look at it again, but I'm going to get a couple more examples up here on the board, and we're going to keep factoring by putting things into groups. So hang on just a sec. Okay, we got some more stuff up here. I'm going to do two different kinds of things, and I'll probably go pretty quickly. I really would suggest that if you didn't get the thing I did with the boxes, you go back and you watch that again until you're fully convinced that you're allowed to do this. I've written up what I did up here on the top to show you that this type of grouping is the same thing as this type of grouping. But make sure that you understand that pretty well before we go on. So I'm going to take example 2 here. And we're going to do the same kind of thing where we're going to say, hey, we're allowed to put these 4 terms in whatever order that we want to make it more convenient for us. We've got to be a little bit creative and think outside the box. And when I look at this, I see kind of my eye is drawn to the numbers. Okay, I got y's and like 3 of them. So which one would I pair up? Which ones would I pair up? But maybe I should pair up things where the numbers are the same. So I'm going to rearrange this. And I'm going to put that plus 3 here, and then I'm going to group the things with 8s together. Okay, I'm going to take these things separately from these things. All right, that means that I'm going to pull a 3 out and see what's left. If I divide this by 3, I'm left with 1. And I'm going to take this separately, and I can pull out a negative 8 and a y. And I'll be left with what? Y squared plus 1. This is this situation right here. And so I can rearrange this and say 3 minus 8y times y squared plus 1. Now that's not the only way I could have done that problem, but that's a pretty good way. I'm looking for a pattern in there. The 3's and the 8's kind of set themselves up nicely for splitting apart into pieces. And again, I can rewrite this with the grouping. I can rewrite it like this so that I only have 2 factors, and you can double check by foiling it. 3y squared plus 3 minus 8y cubed minus 8y. It's all the pieces that we started with, just maybe in a different order. The second example is going to be with greatest common factor. Now as you look at all the terms here, you got 45s, 15s, and 5s. It's hard to tell with the numbers what might be good to group together. But you look at all the letters. Each one has an A in it, and each one has at least a squared in it. Each is divisible by 5. So we're going to take out some stuff out of the front, and then we're going to be left with a lot of stuff that maybe we can do some more sorting and grouping with to simplify. So everything in here is divisible by 5, and everything in here can have an a squared factored out of it as well. And when I take that out, 45 divided by 5 is 9, and then I'm left with an a and a b out of this first term. Out of the second term, if I divide it by 5, I'm left with 3, and if I divide out an a squared, I have an a left over. This third term, if I divide out of 5, I'm left with 3. If I divide out an a squared, all I'm left with is the b. And then out of this last term, I divide the 5 out, that makes 1, and I divide the a squared out, that also makes 1, and that's what I'm left with inside. All right, now, do we group the a's together or the b's together? I don't really think it matters. I'm going to take these two, and I'm going to take these two separately and group them, and then we'll see what we've got. So here they're both divisible by 3 and a, and when I separate that out, I'll be left with a 3 and a b out of the first term, and out of the second term, I've divided 3a by 3a, and that leaves me with 1. I think you're seeing what's coming up here. I'm going to kind of fudge a little bit, and I'm going to take out a plus 1. I'm going to factor out a plus 1. And what does that leave me with? 3b minus 1. Our rule up here says after we've taken out 5a squared, we can regroup this as 3a plus 1. Both 3a and plus 1 gets multiplied by 3b minus 1. And there's our grouping. We have 3 parts, with out here being our greatest common factor, and out here being a problem that was similar to this where we can rearrange before we group. This is something that you're going to need some practice doing until you can kind of feel comfortable with moving the pieces around to make it more convenient. But the nice thing is, even if you don't do it in the most convenient way, you can still factor stuff out and be left with the right answer. You just may not find the path of, or the math of least resistance. So there you go. There's examples 1, 2, and 3. We'll come back with the next episode to tackle the other 2, which will need a little bit more time.